us solve this question from GATE 1996. Question is very fundamental and we will be spending little bit more time on this question. Question is, which of the following is false, and four different options, four different formulae are given to us. Now if you observe all the options, each option is involving an implication and they are asking us whether this formula is true or false. Now first thing to observe here, when we say that a particular formula is false, that means that formula will always be false, it can never become true. So we have seen three different types of formulae. One is tautology, which is always true. Then we have seen contingency, which is sometimes true, sometimes false. And then third category of the formula is contradiction, which is always false. And the question is asking which of the following is false, which means which of the following is always false. Though that word is not written there, we can assume that word. And therefore, simply saying the question is asking which of the following formulae are contradictions. So first thing, you should assume and always here. So when the question says which of the following is false, it means which of the following is always false. And we will see two different approaches to solve this particular question. Actually there are three approaches to solve the question. First one is by observation, second one is by solving, and third one is by what I can say reverse substitution. So we can check whether an option fits into the question format or not. So let us see the first option. We will try to solve this option one by one. So let us consider option A. It is x and y. Sorry, x implies y and x implies y. Now first of all, let us try to solve this particular question. What will happen? We will apply the formula for this implication. It will become negation x or y and x implies y. So the outer implication I will keep as it is. Inner implication I have expanded with the help of formula. So left hand side implies right hand side can always be written as negation of left hand side or right hand side. Now simply by changing the sign I can write it as x and negation x or y implies y. Okay, so whenever you have got and operator, the side can be changed. A and B can always be written as B and A. Now let us apply the distributivity law. Therefore this will become x and negation of x or x and y implies y. Now x and negation of x will always become false, and false or anything will remain the same thing. We are applying the identity law, and that is why this entire bracket will reduce to x and y implies y. Now after expanding this bracket further, again it's an implication. We can write the negation of left hand side, which is x and y, or the right hand side. Now let us apply the De Morgan here. Negation of x and y will become negation of x or negation y or y, and we know that negation of y or y will become true, and that is why this will become negation of x or true, and anything or true will come out to be equal to true. So what we can say, that option A is basically equivalent to true. Option A is a tautology and therefore option A cannot be the answer. Now in this particular case we are solving the problem. Okay, so this can be called as solving by simplification. The second method you observe, let us try to make this particular option false. If we can make it false, then definitely it is not a tautology, and therefore we will be considering this option. But if we cannot make it false, see any formula, if you cannot make that formula false, what is the meaning? That formula is always true, and if the formula is always true, that particular formula will be called as tautology. Now this formula is basically an implication, this outer implication, left hand side implies right hand side. So what we will say, in order to make this implication false, okay, when an implication is false, whenever the left hand side is true and the right hand side is false, in that case the implication becomes false. So the right hand side is simply y, and therefore what I need to do to make the implication false, we need to substitute y equal to false. And if you substitute y equal to false, this y will become false. At the same time, this y will also become false. You cannot substitute two different values for y. We have already taken y equal to false. Therefore, wherever you see y, its value will come out to be equal to false. Okay, that is one thing. Now, what is the case? We want to make this inner bracket, that is something and something, to be equal to true. Okay, see, it is of the format A and B. It's a conjunction. Whenever you have got something separated by and, it is called as a conjunction. So the entire conjunction we want to be equal to true. So what should be the value of x? See, x can take only two values. Either it can be true or it can be false. But if you make this x equal to false, this entire bracket will become false. But we don't want false, we want true. So what we will do, we will keep x equal to true. Okay, so y equal to false and x equal to true are the values that we will get. And the moment you take x equal to true, this x will also become true. And therefore this implication will become true implies false and true. And what is true implies false? True implies false is false and true, and false and true will become false. So this entire side will become false, implies false, and false implies false is called as true. So what is the important lesson in this particular option? That you cannot make this implication false. This implication will always be true, because we attempted to make this particular implication false. Our basic objective was to make this implication false, but we failed. We could not make that implication false. And if you cannot make any implication false, that means the implication will always be true, which means that the implication is a tautology. And if an implication is tautology, if a formula is tautology, that formula cannot become false. And therefore, option A cannot be the answer here, because option A evaluates to true. Similarly, let us try to evaluate the second option. Option B. So first we will solve option B. Now what is option B? Negation x implies y and negation x implies negation y implies x. So what I will do here for simplifying, we will solve this left hand side first. We will simplify it first by applying the formula for implication. Now what is the formula for implication? It is negation of left hand side. Now entire left hand side is negation of x, and therefore you need to take negation of left hand side. Now that means you need to take negation of x, two times negation, and it will become x, or right hand side which is y, and again negation of left hand side which is x, or right hand side as it is. So this will become negation of y implies x. Now it is x or y and x or negation of y. We can apply the distributive law in the reverse direction, and therefore this will become it will become x or y and negation of y. See, x or we have taken common, and the remaining term will be y and negation y implies x. Now at this point I would suggest you one thing. Whenever you apply distributive law in the reverse direction, you can verify that you have done correct application or not, and you try to solve this particular bracket. We should get back the original formula, original term. So x or y and negation of y, if you apply the distributive law, what it will become? X or y and x or negation y, which is exactly what it was earlier. So we have done the correct thing, and now we can solve further without any mistake. X or y and negation of y will become false, implies x. Now x or false will become x, implies x. Now we know x implies x will always be true, but still we can see it. Apply the formula for implication. Negation x or x, and negation x or x will come out to be equal to true. Again, what does that mean? The second option is nothing but a tautology, and a formula which is tautology cannot be called as a false one, and that is why option B cannot be the answer. Again, let us try to apply the second method here. What is the second method? Let us try to make the implication false. Now how it can be done? We want this entire side true implies false. Now if you want true imply false, the value of x should be equal to false, and when you make x false, here it is negation of x, it will become true. I will write it here. You want true imply false. Okay, we have taken x equal to false. Now when you take x equal to false, this negation x will become true. Here also negation x will become true. Now you take any value for y. For example, you take y equal to true. When you take y equal to true, here the y will become true, and here this negation y will become false. Or if you take y equal to false, here y will become false and this negation y will become true. So you are going to get this combination. Either it will be true implies true and true implies false, or it will be true implies false and true implies true. Okay, because this is symmetry. Here it is y, here it is negation y. So one will be true and another will be false. Y and negation of y cannot be same. Exactly one will be true and exactly one will be false. Now what happens? If you observe these two implications, true implies true will be true, but true implies false will be false. What does that mean? It is implication, and exactly one of the implication will become false. So either it will be true and false, or it will be false and true. And in either case, this entire side will become false, and you will get false imply false, and we know that false imply false is always true. So this is another way to look at the problem, that option B is always true because it cannot be made false. Similarly, let us evaluate option C. Now option C is pretty simple. X implies x or y. Directly we can apply the formula for implication. It will become negation x, or right hand side as it is x or y. Negation x or x will become true. True or y will become true. So again option C comes out to be a tautology. Option C is always true, and therefore that cannot be the answer. Similarly, if you check here by the second method, let us try to make this implication false. So what you need to do, you need to bring it into the format of true implies false. So this x should be made true and x or y should be made false. Now you can observe, the moment you make x equal to true, x or y will also become true, and that is why you cannot bring this formula into the format of true imply false. If you try to make left hand side true, you need to make x equal to true, and the moment you do x equal to true, the right hand side will also become true, because the right hand side involves conjunction of x, and true or anything, you need not be worried about the value of y. Y may be true, y may be false. Independently of the value of y, this x or y will become true if you keep x equal to true, and that is why this particular formula cannot be brought into the format true implies false. Or what I will say, you try to assign such values to x implies x or y. Okay, assign such a combination of truth values to x and y such that your left hand side becomes true and right hand side becomes false, and you cannot do that. We have already seen you cannot have any combination such that this x is true and x or y is false. Simply that is not possible because of x being true, and that is why C also cannot be the answer. And now let us evaluate the last option, which says option D, x or y double implies negation x or negation y. Now let us try to solve this particular formula. What we will do, this x or y we will keep as it is, then double implication, negation x implies negation y. Now we will apply the formula for implication here. It will be negation of left hand side, which is x, or right hand side as it is, which is negation y. And what you are getting here, x or y double implies x or negation y. Now if you observe the formula for double implication, let us take the variables, for example AB and then A double implies B. We will take the values here, false, true, then false, true and true. Okay, so what is the important property of double implication? When the two variables are same, the result will be true, otherwise the result will be false. So false will become true, true will become true, false true will be false, true false will also be false. So the meaning of double implication is equality. So whenever double implication is true, both the sides will be equal. Whenever both the sides are equal, double implication will be true. And here what are we trying to say ultimately? That x or y is same as x or negation of y. So we are trying to say whenever x or y is true, x or negation y will also be true, and whenever x or y are false, x or negation y will also become false. Ultimately what we are trying to say that these two formulae are the same. We are trying to say x or y means the same as x or negation of y. But my simple question to you is, are these two formulae same? Obviously not. X or y cannot be same as x or negation of y. And let us try to assign any combination for xy. We have got 4 combinations for xy. We can go for true false, false true, false true and true. Okay, now first of all let us apply true false. Now if you apply true false, what will happen? This will become true or false, that is true. Double implies, here it will become true, or negation false will be true, that is true. Okay, now true double implies true is true. Now if you apply false true, this x will become false, y will become true, so this side will become true, and false true, so x will become false, negation of true will become false, this will become true double implies false, which is false. Now if you apply false, this side will become false, double implies false or negation false will be true, which is false, and if you apply true, then this x or y will become true, and x or negation of y will also become true, and this will become true double implied true, which is true. And if you observe this, sometimes it is true but sometimes it is false, and we know when we talk about double implication it should always be true, and that is why this particular formula is sometimes true and sometimes false. So the truth value of this formula, truth value of this double implication depends upon the actual values that you are assigning to x and y, and that is why this double implication formula is a false one, and therefore what we can say that option D will be the correct answer, because option D is not a tautology. I hope you are very clear with this particular formula. Okay, again let us try to do one thing. We can do one more thing. Let's try to make true or false. If you want to make true, can we do it or not? Okay, can we make this particular formula false? Now in what case this formula will become false? Either you make this side true, this side false, or you make this side false and this side true. Now whenever you want to make this side false, x should and y, both of them should be equal to false. We are trying to do this, x or y equal to false, that means both of them are false. But when you do so, here it will become negation of x, which is true, implies negation of y, which is true, and true implies true becomes true. So this formula can be made false double implies true, and you know that false double implies true is false. Okay, so the double implication is not satisfied, false and true are not same, and that is why option D is the correct answer here, because option A, option B, option C are tautologies. Option A, option B, option C are always true, they cannot be made false, and therefore option D will be the correct answer. Okay, I hope you are clear with this formula. Again, just before exiting with this question, the summary is option A, option B, option C are tautologies and therefore they cannot be false, and therefore option D will be the correct answer.